Congruence and inequality properties in an isosceles triangle. Theorem 3-4, the isosceles triangle theorem. This states that if two sides of a triangle are congruent, then the angles opposite these sides are congruent. For corollary 3-4.1, it states that every equilateral triangle is equiangular. While for corollary 3-4.2, it states that each angle of an equilateral triangle has a measure of 60. Now let's move on to Theorem 3-5, the converse of isosceles triangle theorem. This states that if two angles of a triangle are congruent, then the sides opposite these angles are congruent. For corollary 3-5.1, this states that every equiangular triangle is equilateral. Now, for the inequalities in a single triangle. We have Theorem 3-6, side angle inequality theorem. This states that if one side of a triangle is longer than the second side, then the measure of the angle opposite the longer side is greater than the measure of the angle opposite the shorter side. Next, we have the Theorem 3-7, the angle side inequality theorem. This states that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Then, we have these inequalities in two triangles. We have Theorem 3-8, the hinge theorem. If two sides of one triangle are congruent to two sides of a second triangle, then the included angle of the first triangle has a greater measure than the included angle of the second triangle. Then the third side of the first triangle is longer than the third side of the second triangle. For Theorem 3-9, the converse of the hinge theorem, if two sides of one triangle are congruent to two sides of a second triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. Overlapping triangles. We have here example number 1. The given is line AB is congruent to line ED, line AC is congruent to line EF, while line BF is congruent to line DC. Let us refer to the figures shown. Prove that triangle ABC is congruent to triangle EDF. So this is the two-column proof for the example. This is another example. The given, wherein angle ACB is congruent to angle DBC, line AB is perpendicular to line BC, line DC is perpendicular to line BC. Let us refer to these figures. Prove that triangle ABC is congruent to triangle DBC. So this is the two-column proof for the given example.